plus H2O, water. So base plus acid gives salt plus water. This reaction is known as neutralization reaction. This reaction is known as neutralization reaction. Now, what happens when an acid reacts with metal oxides? What happens when an acid reacts with metal oxides? When an acid reacts with metal oxide, it gives the products salt and water. It gives the product salt and water. So, in the neutralization reaction also, we are having the product salt and water. Here in reaction with the metal oxides, the same result, we are getting the product salt and water. So, we can say that when a metal oxide reacts with an acid, it gives salt plus water. CuO plus 2HCl gives CuCl2 plus H2O. CuO means copper oxide plus 2HCl. HCl means hydrochloric acid, that is a metal oxide plus an acid gives CuCl2, copper chloride, which is a salt, plus H2O, that is water. So in general, metal oxide plus acid gives salt plus water. Now a new term we are going to study, that is amphoteric oxides. Amphoteric oxides. Some metallic oxides react with acids only. Some metallic oxides react with bases only. If metallic oxides react with both acid and base, then they are known as amphoteric oxides. Some metallic oxides are said to be basic in nature because they give salt and water on reacting with acids. Some metallic oxides but react with both acids and bases. Both acids and bases. Such oxides are known as amphoteric oxides. Such oxides are known as amphoteric oxides. So what do you mean by an amphoteric oxide, or what is an amphoteric oxide? How we can answer the question? Some metallic oxides react with both acids and base and are called amphoteric oxides. Those metallic oxides reacting with both acids and bases are known as amphoteric oxides. Okay. The next important topic in this chapter is alkalis. What do you mean by alkali? All bases do not dissolve in water. An alkali is a base that dissolves in water. So simply we can say that alkali is a base that dissolves in water. An alkali is a base that dissolves in water. All bases not dissolve in water. Only those bases which dissolves in water are known as alkalis. Only those bases that dissolves in water are known as alkalis. Common alkalis are sodium hydroxide, represented as NaOH, potassium hydroxide, KOH, calcium hydroxide, CaOH twice. So in general we can say that those bases that dissolve in water are known as alkali. But all bases do not dissolve in water. So we can say that all alkalis are bases, but all bases are not alkalis. Give reason. All alkalis are bases, but all bases are not alkalis. How we can explain this point, or how we can give the reason behind this point? We know that alkali is a base that dissolves in water. So simply alkali is a base, but the condition is that they must dissolve in water. But all bases are not alkalis. All bases do not dissolve in water. Only some bases dissolve in water, and that are known as alkalis. Others don't dissolve in water. So we can say that all alkalis are bases, but all bases are not alkalis. Now, when we mix water and acid, what we could do is just slowly acid must be added to water. Never ever add water to the acid. So when we need to mix acid and water, two options are there. Water is adding to acid or acid is added to water. So which step would you follow? Never ever add water directly to acid. Only do acid must be added slowly to water with constant stirring, because acid reacts with water is a highly exothermic reaction. So when water is directly added to acid, due to high exothermic reaction, explosion may happen, or due to high heat released, the container may break. So what you could do is, acid must be slowly added to water. Small amount of water is added, small amount of acid is added to water with constant stirring. Then what happens? It completely reacts and the heat evolved is reduced slowly. So chance of an explosion is not happening there. So in case of mixing acid and water, only do acid slowly adding to water with constant stirring. Okay, that's it. What happens when a non-metallic oxide reacts with a base? When a non-metallic oxide reacts with a base, then they react together to give salt and water. So we know that when an acid and a base reacts together, we get salt and water, and the reaction is known as neutralization reaction. Here the same case happens when a non-metallic oxide reacts with a base, gives salt and water. So that simply means that a non-metallic oxide is acidic in nature. If a non-metallic oxide is acidic, then acid plus base gives salt and water. The reaction is correct and is neutralization reaction. So we can say that a non-metallic oxide is acidic in nature. So in general, we can say that a non-metallic oxide reacts with a base, gives salt and water. A non-metallic oxide reacts with a base, gives salt and water. For example, CO2 plus CaOH twice gives CaCO3 plus H2O. What is CO2? It is carbon dioxide. This is a non-metallic oxide because carbon is a non-metal. Plus CaOH twice, calcium hydroxide, which is a base, gives CaCO3, salt plus H2O, water. Non-metallic oxides are acidic in nature. Why we are saying non-metallic oxides are acidic in nature? What's the reason? We can give reason. Non-metallic oxides are acidic in nature. How will you explain this? Just write the equation: non-metallic oxide plus base gives salt and water. We know that when an acid reacts with the base, gives salt and water, and the reaction is neutralization reaction. For getting the product salt and water, then non-metallic oxide should be acidic in nature. Then only acid plus base gives salt and water. That's why we are saying non-metallic oxides are acidic in nature. Now what happens when acids or bases reacts with water, or acids or bases in water? Acid produce H plus ions in presence of water. So when acid in presence of water produce H plus ions. For example, HCl plus H2O gives H3O plus Cl minus. HCl is an acid. In presence of water, H2O gives H3O plus ion. H3O plus ion means hydronium ion plus Cl minus ion, chloride ion. So H plus ion cannot exist individually. H plus ion cannot exist individually, cannot exist alone. They exist as H plus in aqueous form or H3O plus hydronium ions.